All right. Good afternoon. My name is S.Williams. I am a fifth year biology teacher, and I will be going over my methods portion. I want to start off by saying I apologize for the lateness of this. Again, this was in Module 1, and I was not aware that these things were being added. Later on, after I had already submitted the assignments. But the assignment required me to go through the natures of science, cultural norms that we see in science, and the implements for teaching. And me, as a person that got my bachelor's degree and my master's degree in sciences, I got two bachelors, one in biology, one in chemistry, and a master's in uh, kinesiology and the medical sciences. I have done a lot of practices with science, and I've done a lot of work with sciences, and now teaching students the sciences that I learn and I enjoy is imperative. So I have some key characteristics that I came up with the natural scientists and how they play a role in the development of a proper student and the things that we see culturally and normally in our science life. So our science knowledge is grounded in observation. Everything we do, I tell my students all the time that I am a database person. I need to see the numbers. I can't just make a conclusion. I have to see what happens in those numbers. So we have to observe, we have to measure, we have to take data. And when we are observing, we have different shapes and tools to do that, whether that's using a microscope or giving out a survey and using the information that we get from that survey. We're also tentative but durable. So when it comes down to our scientific knowledges, um, it's related on what we see in that experiment that I've done. So I can get all of these things and I can make it practical and say, okay, this is a fact, this is going to happen every time. And I can also test that and get the same result all the time. Or I can come up with some completely new concept and try to figure out what's likely going to happen in the future and what could happen later on. So it's a very tentative and durable concept, which leads me into my third characteristic is theory driven. Everything came up from a thought. Some scientist somewhere said, maybe this could happen, maybe that could happen. And so let me see. Let me figure it out. I want to see what's going to happen. Science is curiosity driven. You have to be curious about things. You want to find things out. And that's one of the things that really drove me to actually pursue science because I was always the person that always wanted to learn something new. I always called myself a forever student. So I always was curious, and science is you're always curious, you're always poking, you're always prodding. There's always some theory that I'm trying to figure out, is that true or is it not true? We can also influence human creativity and imagination. Again, like I said, for me, it was let me see if this is possible. I can come up with something in my head. I always like for me and my family, I have two siblings with a genetic disorder. And I was always like, oh, what does the Punnett square look like for my family, for my parents? So are both of my parents carriers or one a carrier? What happened? So doing those things and seeing what they look like is always something interesting that I see in the science field. And it's also a social and culturally embedded. A lot of the things that we discovered started with religion, or it started with somebody just being curious about something that's happening. It's a social aspect that you could talk to the next person. Let's figure out this. Let's figure out that. It can also be political, economical, ethical. All of these things can be embedded inside of science. Okay, so some of the cultural norms that I talked about was the historical exclusion and representation. Um, for centuries, scientists and institutions have disproportionately studied different aspects, whether it's gender, economic values in the scientific world, and some places there were some you had to be privileged to study science. All right, so in order to be a scientist, historically, you either had to be male or you had to have some type of economic advantage. And that was the norm back then. So if you go back and look at history, there's not too many females that had some great scientific discovery, like Gregor Mendel with genetics, um, Darwin with evolution and natural selection. It's always some type of man that discovered it. Sir Isaac Newton and his theories, always some type of male, and a lot of it was based off of religion. Think about it when we were talking about that the earth, that they said the earth was the center of the universe, and God created the earth and everything like that, and refuting those things was going against the church. Values of skepticism, peer review, and transparency. When it comes down to science, science is the most transparent thing. One thing I was taught when I was in undergrad is that as a scientist, you do everything in pen. You never want to erase something because it comes off as that you're hiding something. You want to make sure that somebody can see what you did and that you're not making up things. Everything is transparent. We can see it. You have peers that review it. Somebody else is going to test it and see if it happens the proper way. We have to go through research and make sure that everything we do is based off of some type of scientific method. So it's very, very specific in those aspects. Um, and it shifts societal needs and shapes scientific agendas as well. So when it comes down to public health, we have vaccine development, climate change. We develop renewable energy, agriculture. We figure out how to genetically engineer and modify certain fruits and vegetables so that they can grow in certain situations, and also genetically modify animals so that we can get as much as we possibly want. These sciences are driving everything in the world, and I try to get my students to realize that science is involved in everything. Every aspect of your life has science in it. So why you ask me, why do I have to do science, why do I do that? Because science is life. That is what it is. All right. And power, funding, and access. Scientific research is often influenced by who can fund it. So the government, some type of corporation, or a university. So I can only do my research if somebody backs me and fund me, if I have the resources and the money to do it. So if nobody's backing it, it's really hard to actually do those scientific studies because a lot of them take time, years, months, decades, so to actually see. So, connecting this to my teacher practices, I did give some examples of some other things that I like to do. I do CERs, and this is my way of getting my students to actually do some more reading because in my district, literacy is a big portion, but also getting them to explore science, having them to pick up something that they feel is important or interesting, and to get them to read about something that they want to read about and to learn something new. Help them be able to develop an argument and have the ability to use supporting resources to back up that argument, and that also helps them with being able to develop a point of view in their adult life. Um, So teaching scientific knowledge changes that we've seen. So there's a lot of I tell my students that science changes all the time. We always discover something new. Something's always going to be different from what you've heard before. Um, Before they taught you very little details, and the further you go in the subject, the more details you get and the more finite we get down into that information. So we will see changes and we have to adapt to those changes. Just like in science, everybody has to be able to adapt. All right. So also I like to make sure that my students can see themselves in their science. Like currently in biology, we're doing genetics. So we try to do things that are based off of things that they know. So your eye color, your hair color, how did you get that? What color are your parents' eyes? What color is your siblings' eyes? So we try to base it on those type of things, and then we do real life based labs. We did a lab for cell transport using dialysis tubing. We've done actual photosynthesis lab and seeing color changes based off of the presence of carbon dioxide in our experiment. So we try to do a lot of stuff and so that they can see how it relates to them, because a lot of the time my students ask why I got to do this. So we want to make sure that they know that they're doing this for a purpose and they can see it in real time in real life. I also like to do some integration of data. I like to have my students be able to look at the numbers, and I do this a lot with their test scores and their quiz scores. And I'll pull up a grid or a pie chart or something showing them their test scores and showing them, okay, this is where we are and this is where we need to go. And I have them to be able to interpret those graphs. And I also do it with scientific research based things as well. What percentage of our population has this, that, and the third? So we try to get them acclimated with these things and try to make them more relatable to themselves. So I hope this has been insightful, and I thank you so much for hearing me out. I do apologize for the time limit again because when I am talking about science, I'm extremely passionate, so I tend to go overboard. I hope you all have a great rest of your day.